All right, boys and girls, today we're going to look at addition and subtraction equations. And so, when you are learning about equations and you're kind of going through, solving equations, you're going to run across addition and subtraction equations as well as multiplication and division. On this one, we're going to look at addition and subtraction only. And so, when you're solving these problems, again, you're trying to think about solving for the unknown. And in this case, the unknown, a lot of times, is going to be a variable out of the alphabet. And so, what you're going to see here on this particular page is a word problem where they've taken what kind of looks like a strip diagram, or what some teachers use as part whole, and they're kind of setting that up in a model so you could see it kind of forming into the equation. So I'm just going to go over this problem with you, and we're going to talk about what you should think about when solving these. I think this Janine. Janine went to the beach 22 times during July and August. 6 of those times were in August. How many times did she go in July? So what you're really thinking about here is you're looking for the unknown, which they've labeled with the letter D out of the alphabet. And so they've kind of already set it up for you. But basically, what you would want to think about on this particular picture or this particular problem would be that they started you out and they gave you the total. So a lot of times, whether you're solving for equations or not, when you're just problem solving, I always go back to the basics of, your four operations. You're either going to add, subtract, multiply, or divide. And in this case, since they're going to give you the total, how many times she went to the beach, both in July and August, they're starting you off with the total. So another way to see this could be part whole, which is basically the same thing, but it's just going to be me kind of doing it on my own out to the side. They gave me the total, and then they also gave me how many times she went in August. So she went 6 times in August, and then I don't know about July. That's their question. So a lot of times when kids are solving equations or solving problems, and they get stuck, one of the things that you need to always keep in mind is, part whole or strip diagrams are really beneficial, helping you decide what to do and when to do it. And when I say that, it's what type of operation should I use in this scenario. So in this scenario, I'm really thinking about two different ones. I'm thinking either subtraction or division, and that's because in my part whole, if I'm ever missing a part, I know that my two options are going to be either subtraction or division. And so they did that on theirs as well. I'm missing D. And so if I wanted to solve this, even though it's going to be a pretty easy solve, I would think to myself, okay, well, I need to take the whole, which is 22, and I need to find out about the missing part. So in this case, I'm going to subtract 6, and that's going to give me D, or how many times she went in July. And so if we did that, 22 minus 6, again, depending on where you're at mathematically, you could solve that one mentally, or you could set it up and solve it. So finding the answer to that one or looking at an equation is pretty simple. But again, just kind of go back to your basics with part whole. You probably did that last year or even down in third grade. Or even strip diagrams. Those have been around for several years now, so those should be pretty easy. All right, so here's just another example of a word problem. This one here, it says Joe scored 45 points. He scored 12 fewer points than Randy. It says how points. I think it should say how many points did Randy score. And so, looking at this particular setup, we know about Joe, and we know that he scored 12 fewer points than Randy. And then they want to know how many did Randy score. Then, kind of thinking how they set it up. Again, it's in a strip diagram. You could think of it in a couple of different ways. Here, part of what Joe scored is, or excuse me, all that he scored, which was 45 points. And then you know that he also scored 12 fewer points than Randy. So you know Randy's going to have a bigger point total. And so here, it's kind of like, all right, they gave you two parts. They gave you 45 and they gave you 12. So you're looking really to combine those two. And it's kind of tricky because of how this one's worded. But if you know that Randy scored more and you know that Joe scored 45, which was 12 less, then you're going to have to take the 12 and add it. So our equation here would be 45 plus 12 is going to give me S, or what Randy scored. And again, setting it up mathematically, it's either going to be 45 plus 12 in an algorithm, or solving that one mentally to get the answer of 57. I could think of it as part whole. I know that one of my parts is 45. I know my other part is 12. And so in this case, I'm missing the total, or I'm missing basically Randy's score, or how many points he scored. And so I'd have to set that up as an addition problem, which we found out he scored 57. So not too bad. Just kind of go through that, think about it again, think about those strip diagrams, think about part whole, and how you could use that to your advantage. All right, this particular one is more of a just straight word problem, and you don't have kind of the assistance there of a strip diagram. So a lot of times what I like to do, and I think most teachers like to do this, is when you're solving an equation problem, when your answer choices are all equation options. In other words, they've given you 4 different equations to choose from. What I like to do is I like to just, as best as I can, not think about those. So I'm going to kind of pretend doing that on this problem. All right, so now that the answer choices are covered up, let's just kind of read this thing. Let's see if we can't put together either a strip diagram or a part whole model, and let's see if we can't figure it out. And then from there, we'll uncover the answer choices and see which one makes the most sense. Okay, it says Stan spent $18 on giant carrots at the giant vegetable store. He also bought a bag of giant peas, but the bag had no price tag. Stan was charged a total of $23. Which equation can help you find the cost of the peas? All right, so I'm going to first start with their variable. They're wanting to know about peas, so they're using a letter P, and that's really our question here. So this is kind of what I'm picking out of the problem. I know that he spent $23, and I know that he bought 2 things. He bought giant carrots, and I know he spent $18 on that. And then I know he also bought the giant peas, but I don't know how much he spent on that. So to me, this is just classic strip diagram or part whole. All right, so I'm going to first go with what they gave me. They gave me a total. And so since they gave me a total, right off the bat, my brain kind of shifts towards subtraction or division. I'm not going to pick one of those just yet, but I'm already kind of thinking in that direction. I also know that they gave us a part, or they gave us, one of the things in the problem was carrots, another one was peas. Well, they gave us carrots, so I might put a C there for carrots. But I don't know about the peas, so I'm going to put that there. And so when I'm breaking this down, I'm really kind of thinking about what is the best operation to use in this scenario. Well, in this particular one, if I'm limiting it down to subtraction or division, basically I want to go for the one that makes sense, or I want to go for the one that is reasonable here. Division is not reasonable at all. Subtraction makes sense because I know if I take my total, which is 23, and I go subtract 18, I'm going to find how much those peas cost. Now, they're not a lot. And so, he spent the majority of his money on carrots. So I know that this is going to give me a small answer. So I'm going to just do some regrouping here. I'm going to go through this problem and find out that 5 is really what I'm looking for. P equals 5, in other words, so I could write that in there. Okay, so what I'm going to do now is I'm going to go back to my answer choices, and this is really where you have to be careful, because these equations are designed a lot of times to fool you. And when you go super fast on an easy problem, I mean, think about the math we just did. The math there was probably first or second grade math. But they are designed to throw you off because they're set up in an equation. In other words, if you just had to go find 5 and do 23 minus 18, that would be really simple. But since you're having to find the equation to match, sometimes what they'll do is they'll throw a kind of an odd looking equation at you, and it's kind of designed to either throw you off, or it's designed to, kind of look like it's wrong, but actually it could be right. So you have to be really careful. So I know A right off the bat is wrong because I did not add 18 and 23 to get P. If I were to look at B actually looks kind of good at the beginning. In fact, I think it's the one that they want you to go for. But if you really go slow and you think about what we didn't do 18 minus 23. Yeah, we did a subtraction problem, but we didn't do 18 minus 23. That actually would get you a negative number. And so we don't do that in 5th grade, so B is out. If you look at C is saying that 18 plus something, in this case 5, is going to give you 23. Now, I think that one makes sense. That one doesn't necessarily match what we did, but it makes sense for our setup of our problem here. If I go to D, if I place a 5 in for that, 23 plus 5 is not 18, so D does not make any sense. And so I'm going to go with C. Even though maybe we didn't use addition in our problem, that could have been used as like a check. In other words, I could have done what's called the inverse operation, and the inverse operation would have been doing an addition problem to check my subtraction that I did. So, looks a little bit different when they show up like these. You just have to be really careful and watch for that, because they are going to try to trick you. All right, so this will be our last problem. Looking at this one, kind of the same setup as the last one. This time I'm not going to scratch out the answer choices, but I'm not going to look at those until I'm done solving. In other words, I can already tell on this before I even read this, I'm going to be solving for B. And so we're going to find out what B equals, and then we'll go over to our equations. Okay, it says Morgan has 28 pieces of jewelry. I'm going to go ahead and mark that. So as I go through, I know that's going to probably come back and be important. So she's got 28 pieces of jewelry, 10 of which are necklaces. Okay, so I know that 10 are going to be necklaces. So as I'm kind of writing this and solving it, I might write some stuff out to the side. So I've got 10 that are going to be necklaces. It says the rest of our jewelry pieces are bracelets. Okay, so I know that there's going to be a B here. Which equation can you use to find the number of bracelets? Okay, so pretty basic here. I've got some jewelry. I've got a total. And my total here is going to be 28. And then I've got 10 necklaces, but I don't know about bracelets. So I'm going to set up kind of on the last problem, kind of the same setup here. I know that I'm going to have 28 as a total, and then I'm going to have 10 necklaces, so I can put an N next to that. But then I'm going to put my B here, or my question mark, which is I need to go find out how many bracelets that she has. So it's almost the same setup as our last problem, where I'm looking for a part or a piece. And so I'm going to think subtraction or division. That comes to mind first. Division does not make much sense there. It's not reasonable. And so I'm going to take 28 and I'm going to go and subtract 10. All right, 28 minus 10 is a really simple problem. I'm going to have 18 as my answer. So I'm going to circle 18. And then as I circle 18, I'm going to kind of just draw an arrow back up here for my bracelet. So I know that on this particular problem, she's going to have 18 bracelets. Okay, So now I need to look at my options for B on all my equations here. And again, in the back of my mind, I have to think it's got to make sense. I've got to fit in that answer and it match up correctly and it's reasonable. Okay, so let's just start with A. A lot of these you just got to go through all of them. So A is B equals 10 minus 28. So if I put 18 into that equation, 18 would be sitting on this side, and 10 minus 28, that's going to give me a negative number, so A is going to be out. B says 18 equals, so if I put 18 in there, 18 equals 28 minus 10. Well, that kind of matches what we did here. So I'm probably thinking B's pretty good. C is saying that 28 equals 18 minus 10. Okay, well, we didn't ever do 18 minus 10, and 18 minus 10 would not give me 28, so that doesn't make any sense. And so the last one, 10 equals 18 plus 28, because we know that B equals 18. Well, 18 plus 28 is going to be much larger than 10. And so again, I'm looking for something that makes the most sense. And on this one, B is the one that makes the most sense. So these are not very difficult problems, and they really won't be on the star either. You just have to know. You have to take your time. You have to make sure that you're not rushing and picking something that is not reasonable. And you just got to try to balance that equation, and you got to try to find something that matches with the variable in that particular equation. In other words, that you could plug in that number for that variable. In this case, like we plugged in 18 for B. And then from there, that equation makes sense, and it's balanced, and everything's looking good.